Going on now to the review of practice relating to topic 3.3, quadratic functions. Now, many of these are in multi-parts, so again, reflecting our flipped classroom lesson where I go over the learn, this is what you should have viewed and taken good notes and studied prior to doing these on your own. This is some we'll do together, and then you'll do some practice perhaps, and then the certify. To start our review, I might ask, what is the name of this form in function notation? Well, this is standard form of the quadratic equation. And this in function notation is the vertex form. Now, we've gone over this quite extensively, and in this one, in the flipped classroom lesson, but let's review it a little bit. Why do you think this is called the vertex form? Because you could pick out the vertex of the parabola. And a quick review of that is if our A value is negative, the parabola will open downward. If our A value is positive, it will open upward. The vertex, when A is negative, is the maximum. If A is positive, the vertex is the minimum. And the vertex is this highest point or lowest point. And you could pick it out from this formula. So what would the vertex be? Well, it's going to be H, K. And that is before it goes into this formula. So our step one, here's an equation in vertex form. What is the vertex? Now, we know the K value is just as it appears. That's going to be a -4. But our H value is a little bit tricky because it's the opposite sign of what is here. So it looks like it would be a -5. Well, it's actually a 5. And what does that mean? Well, on the parabola, and our A looks like it's positive here, it's going to be the minimum, that is the point at the bottom of the parabola. Okay, so part 2 now is we want to find the zeros, that is the X intercepts. So to do this, we want to have our Y value here, and I'll erase this, as a 0. So we're going back to our standard form. Well, this is in vertex form. So what would our protocol be? Well, we have to say this will be 0 and put it in this form, standard form, from its vertex form, and then solve this equation when y is 0. All right, let's do that. We could do it together. I've expanded this binomial to x squared minus 10x plus 25. And that equals 0. So we're going to put it in standard form now. This now becomes a plus 21 equals 0. Now this factors, so I can factor it. X, 7 and 3. So this is going to be a negative and a negative, equal each of the factors to 0. So here I get x equals 3, and here I get x equals 7. So they want us to find the x intercepts. Now this is general. This one would be here where this would be a 3. Our 7 would be over there, and the parabola would probably look like so, just to give you an idea. But as ordered pairs then, this is going to be 3, 0, and this will be 7, 0. So we've done quite a lot with this so far. Our next step is to find two other points on the graph, and to do that I would make a t-chart. And it's perhaps easiest to do it in this equation. Now we have a 3. Let's try a 2. And let's try a 0. 0 should be nice to work here. So if x is 2, and I'm going to pause while I do that, and you can do it also. So the easier one, if x is 0 here, x is 0, y would be 21. And if x is 2, this is 4 minus 20 plus 21 gives you a 5. So these are some other points that they are asking you to find. I'll now move it up, and we'll see what our graph looks like here, which is our next example. Now we set our minimum, the vertex of this was 5, -4. So we go over 5, down 4, and there's that. The 0, 21 for our y-intercept is off the graph, but our 2, 5 is nice. There's 2, and there's 5. And notice our y-intercepts there, 3, 0, and 7, 0. And they'll give you a standard parabola. You'll have to grab and then move to these points to plot it in your software. All right, let's go on. All right, in example 2 now, take a moment to read it carefully. So if a diagram might help too, have a rectangle whose perimeter is 208. And you might recall the perimeter formula is 2 lengths plus 2 widths equals the total perimeter, 208. If we divide everything by 2, makes it a little easier. Length times width is, length plus width is 104. And if we solve for one of the values, we can get this. And this then would become, when we put it in the area formula, x times x minus, a minus x plus 104, because we want to put this in standard form. We could put the minus x over there if we wanted. This would then become a negative x squared plus 104x. Our a term is a 1, negative 1. Our b term is 104. We want to find the vertex to get the maximum. So our formula again is negative b over 2a. So b is 110, so a negative b is a negative, 104. A is a negative 1, so this is a negative 2, which gives us then, for a x value here, one of the sides, a 52. Now, if the other side would add up to 104, what's the other side going to be? Well, that's also going to be 52. So even though they describe it as a rectangle, it's better described as a square. And this would give you your greatest area. So what would the dimensions for number 2 be? 52 times 52. Clear this up and go on to the next one. Now here, this is similar to what we've done above. They already have the formula for us. We want to find the vertex of this. What number of apartments would x be to give us the greatest value? And since our a term, and let's put it in standard form, negative 0.5 x squared plus 600x, now it's in standard form, we need to find the vertex. So negative b over 2a. Our b value is 600, so a negative b would be negative 600. Our a is a negative 0.5, so twice that actually gives us a negative 1. So this answer here would be 600 apartments. And these two were related. This one was a little more complicated because we had to work with perimeter and then area. Here they already had it in its formula form. We just had to put it in standard form. All right, let's go on. In example 4, as we look at it, we're looking for use of the quadratic regression software, or whatever we're going to use to find it out, and then what parabola best suits this data. And we're going to use that least averaging technique, but that's all built into the software. And what do we need to do to move forward on this? Well, the protocol is to find these ordered pairs. So this one, it would be 0, 6. This one is 3, negative 3. And this one is 4, 6. And we have these listed here for you. Now, putting this data into the software, and you want to be able to do this properly. I'm going to erase this and move it up. And the resulting function form of the quadratic equation would be this. I've done this one and gotten the answer 3x squared minus 12x plus 6. And that's all they're asking here. Now, I might ask the question, is this going to be a parabola that opens upward or that opens downward? Well, again, you look at your a term, it's positive, so this parabola will open upwards. And we'll probably end up looking something like so, but just to give you an idea. Interestingly, if you go to the site desmos.com, which I feature, you could put that in there if you don't have a graphing calculator yourself and get a good idea what the graph is like. Now, we're calling this number 5, but it actually relates to the previous example. Here's the formula now they're giving us, and we're asked to first identify in standard form what is the A, B, and C. Well, our A will be 3, our B is a negative 12, and our C is a 6. Now, continuing, they're asking us to find the vertex, but using, and remember the vertex is h comma k, which is a form of x comma y, and since a is positive, will be a minimum. So take a moment, you're going to have to pause, put this data into these formulas, and it's a little tiny here. I can make it actually bigger. Pause it at this time. There are your values, A, B, and C, and see if you could find the vertex. Again, this is practice using this substitution. So check your work. B is a negative 12, so a negative B would be a 12. A is 3 times 2 is 6, so 12 divided by 6 is 2, which is what they're giving us as an answer. And here, just substituting, 4 times 3 times 6 is 72, minus 144 is a negative 72, divided by 4 times 3 is 12, is a negative 6. We have found our vertex to be this. In example 6, I left off the instructions, and it is basically looking at the graph, what would the equation of the parabola be? And the protocol for solving it, we go over that in our flipped classroom lesson, is to find the X intercepts, that is the 0. So as we look at that, this would be a negative 3, and that would be 0. And this one would be a 1, comma 0. And that's what would go in this answer box here. So from this, let's put this in the standard form of the vertex. So this would look like A times in parentheses. Now, to get this, this would have been a positive 3 here, x plus 3, and this one would have been a negative 1 to get a positive 1 for the answer. So this would be x minus 1. And that would equal some y value here. So we've got the start of this, but we need another point to find out what our a value would be. Well, we know over here that when x is 0, y is going to be a negative 3. So let's put that there. Wanted you to see where this is coming from. And we know our x values here were 0. So we can erase this. This is just a 0. So we're going to get that as we solve for our a value. Let me write it here. Negative 3 equals, this is a negative 3 times a is a negative 3a. If we divide both sides by a negative 3, we get our a value is 1. So if our a value is 1 here, by going back to what we had before, our a value is now a 1. And then foiling this, we get this. And putting it in standard form, this is the equation of this parabola. And reviewing once again, we found the intercepts, worked backwards, found out what an a value would be, and then solve for that a, and then put it into standard form of the quadratic function. Now in the notes for this, you see we've written up some of the places. There are your values. We want to solve for a, which we've done. So our a was actually 1. And we've given you, I may have left out the answer box for that. And let's go on to another regression problem. We want to find the ordered pairs for these and the best parabola that would suit this using the least averaging technique. So pause for a moment and identify these ordered pairs. Did you get these? Let's make it bigger. Now they want you to put this into your software to find the equation, and you want to round to 3 decimal places. Here we ended up with just needing 2, and there's the answer to this. Now, as we scroll up, what I've done is I've gone to Desmos, and I captured that screen. I put in the quadratic equation they gave us, which is this, and this is the graph that I got out of it. Now notice what it's doing is averaging these points that were the original scattered points on that graph that we have above. But through that method of least averaging and using the software, this was the parabola that came out of it. Now, what might we pick out here? Well, what is the vertex? Well, we really can't tell because it's not on a grid line, but we could use the Vertex Formula to find them. And I'm not sure they're asking for this. Let me look ahead here. No, we're going on to another example. Now in this next to the last example, we're asked to find the vertex. And we're going to go through a series of things. And this is not in the vertex formula. So let's just review. That would be f of x equals a, and then x minus h, the quantity squared, plus k. Now, this is in some kind of way, but it's not standard form, it's not the vertex form. So let's simplify this a little bit here. This is going to be x squared. I'm multiplying these. Foiling it, I get a positive 2x minus 8 plus 9. This then becomes x squared plus 2x, and simplifying this is plus 1. Now I recognize this as a perfect square trinomial already, so I could put this in the form of x plus 1, the quantity squared, and there's nothing left, so there's a 0 out there. So now this is in vertex form. What will my vertex be? Well, it's going to be the opposite sign of this, which is our h, which will be a negative 1, and our k value is going to be 0. So there's our vertex. Find the vertex. We've done that. Now, they want us to find two other points here. So I'm going to make a little t-chart. And I'm going to use a 2 because I've done this already. And just go up a little bit here. And a negative 2. Now when I do that, I get, when it's 2, in this equation here, I get a 9 for this value. And I get a, when it's negative 2, I get a 1 for this value. So now I've found a number of things here. Now this only has the one point where it touches the x-axis, and that is also the vertex. Now my y-intercept I can find right there by saying if x is 0 here, if x is 0, what will my y be? Well, it'll be a 1. So my y-intercept is 0, 1. And that's showing up very nicely. Now I put in there the negative 2, 1. And again, you're asked to graph this. You have to grab and then move to the point, and then the parabola forms using your parabola tool. Okay, so this was sort of an easy one. You'll have practice. Hopefully you'll get some that are easy, some that are more challenging. We want to try to cover as much of the your future certify using these practice examples and showing you the protocol to get the answers as we can. And for our last example, we want you to find the vertex of this. And let's also go, even though it's not written up here, to find the zeros. All right, we'll give you some time. There's our A value, our B value, our C value. There's the H value and the K. See what you can come up with. Okay, did you get for the vertex 3, 4? And for the zeros, 1, 0, and 5, 0. This actually factors. The technique, multiply through by a negative 1, factor it, and it factors nicely. Now, for some of these in the future, they may not factor when you're finding the zeros, and you're going to get radicals. And of course, you'd use the quadratic formula to do that. But these have been working out pretty well. All right, this was probably long enough, and you'll have your own work to do.